What is going on, everyone? My name is Kodamore, and welcome back to the New Beginner Java Game Programming Tutorial Series, episode 20. Now, I know we said in the last video that we would work on collision detection today, but I kind of lied, and I'm sorry about that. I've decided that we've done so much in this game, but we haven't really finished any one part. So for today, we are just going to clean up the world method. Now, I apologize that I'm not doing collision detection today. Don't worry, that will come hopefully in the next tutorial. But for today, we are going to work on making our world's render method right here much more efficient, because currently it is very inefficient. Now, you'll notice in this world render method here, we loop through every single tile in our tiles array, and we basically get that tile and we render it to the screen at whatever position it should be in. But if we run our game here, you'll notice that we can only see part of the screen at any one time. For instance, this rock tile, we can see it right now, but once we move away from it, we can no longer see that same rock tile. Yet the game is still trying to render that tile outside of the screen, even though we can't see it. And it's doing that for every single tile that we have outside of the screen. It's trying to render everything, even if we can't see it. And that means if you have a fairly big map, or even a map as big as mine, which is kind of small, your game is going to be very inefficient because it's trying to render every single tile, even the ones that we can't see. So today we have to create a limit kind of in our render loop, and we have to limit what tiles we actually draw to the screen, because we only want to draw the tiles that the user can currently see. Now this is actually pretty easy to do, but it requires quite a bit of math, so follow along with me. For now, we're just going to create 4 variables. We're going to create an int x start, and we'll just set everything equal to 0 for now, an int x end equal to 0, and we're going to do the same for y start, and an int y end like so. There we go. Now, we are going to set all of these variables to an actual calculation in a little bit, but let's try and explain what we're going to do. Now, if we take a look at, say, our x for loop here, we set x equal to 0, so we're looping from tile 0, or the far left tiles, all the way to the width of our map, or the far right tiles. That means we're looping through this tile right here, the far left, which is x equals 0, and then we're going all the way to the right of our map and stopping at the width of our map, or this tile over here. Now what we are going to do is we are going to change that, and we are instead going to set x equal to our x start variable, and x is less than our x end variable, which we will actually set to something in just a little bit here. But what those variables will contain, x start will contain the tile that the user can currently see that's on the far left of the screen, that is visible, and x end will contain the tile number that's on the far right of the screen that the user can see, but not the whole entire map. And we're going to do the same thing for y, so we'll set y equal to y start like so, and set y less than y end. Now if you try running our game right now, you're going to get absolutely nothing. You don't have a world anymore, because we set everything equal to 0. Now if we set x end equal to width again, and y end equal to height again, we should get everything the same because, well, that calculates to the exact same thing that we had. So all we did is, instead of hard coding 0 and width and height in here, is we changed them to 4 variables that we created up here, and it works the exact same. So now we will begin by calculating x start and x end. X start is going to be the tile on the left of the screen that the user can see, so in this case it would be this tile, or right over here, these tiles. And x end would simply be the tile to the left of the screen, the last tile that the user can see. And as we move, we have to update this number to change x start equal to this tile now and x end equal to this tile, and stop rendering the previous tiles. We can use our game camera, however, we don't want x start to go into a negative number or we'll get a bunch of errors. So what we are going to do is we are going to use a function which is in the math class. We'll do math.max. And max stands for maximum, and it takes in 2 numbers. So for instance, the number 2 and the number 5. And what it will do is it will just return to us whichever of the 2 numbers is bigger. So in this case, it would return 5 because 5 is greater than 2. In this case, we want to return the maximum value between 0. So is 0 greater than, and then we have to calculate which tile is at the left of our screen that we can see. Again, I'll explain this all in the end. In this case, it is going to be game, our game class, .getGameCamera. Get game camera. .get x offset, we're just going to get the camera's x offset, and we're going to simply divide that by tile.tile width, or the width of our tiles. Now you're going to get an error here, and that's simply because we have to cast this whole thing to an integer. So what is this doing? This is simply going to set the x start variable equal to either 0 or whatever this calculation turns out to be, whichever one is greater. So if this calculation right here turns out to be a negative number, so like tile -5, well, we don't have a -5 tile, it will return 0 and we'll just start rendering the 0th tile. However, if this number right here is greater than 0, so for instance the player moved, say, 5 tiles to the right, x start would then equal 5, because we are getting the x offset of the camera, and we're just going to divide that by our tile width, that way we get it in terms of tiles and not pixels. So if we go ahead and run this, you'll see that nothing changes, but in fact, it is only rendering the tiles on the left here that we can see. And if you add 1 to this calculation right over here, you'll see that if we begin moving right, you see tiles are beginning to disappear. So it is working just great. And if we go too far left, where that calculation would equal -1, it's just going to result back to 0, which will kind of start rendering that tile, which is perfect. So hopefully you see how that works now. That calculation is going to only render these tiles starting from where we can see. Make sure you get rid of that +1 or you're going to have that weird effect. Now our xend variable is going to be a bit trickier. We are going to cast everything to an int, and instead of the max function, we are going to use the math.min function. This does the same thing as max, except returns the value that is smaller than the other. Now we want to check, is the width of our map smaller than, and then we have to calculate something. And again, all of this math is really just according to how we set up our game camera. So if you really looked at it, you could easily come up with this math on your own. We want to check, is width or smaller than our game.getGameCamera.get x offset again, plus our game.get width. And we have to add the width because we are now looking at the far right of our screen, not the far left. And we want to take that and we want to divide that by tile.tile width again. Whoops, width. Now if we go ahead and run this, you'll see that it works, except we kind of get this weird effect. And to fix that, all we have to do is add 1 to this calculation over here, and that will get us a smooth effect. So now we have our x start and x end working perfectly. We are only rendering the tiles on the x-axis that we can currently see. Alright, let's do the same thing for y start. It's literally going to be the same thing. We're going to cast everything to an int. We are going to use that maximum function between 0, and this time it's going to be game.getGameCamera.get y offset divided by tile.tile height, like so. And that should work for y, and then we can do the same thing for y end, math.min, the minimum, between the height of our map, and then we want to do game.getGameCamera. It's basically the same thing, get y offset, plus game.getHeight, because we're looking at now the bottom of our screen, not the top of the screen, and we have to divide that all by tile.tile height, like so. Now if we run this, our y is working as well. As you can see here, we get this glitch effect because I forgot to add 1 to the y end. Now if we run it, we get our tiles. It looks the exact same, like nothing changed, which is kind of saddening that nothing changed in our game. However, it is much more efficient. Now if you have a gigantic map, you can have a map full of so many tiles, yet only the tiles that the user sees is going to be on the screen. That's about it for this tutorial. Let me go through this one more time and really kind of explain these calculations. So obviously we are indexing, or kind of setting the variables in our for loops equal to the variables up here. So for x start, or the tiles on the far left, we're checking, is 0, which is the furthest left tile in our whole entire world, greater than this right here. And this is going to be our game camera's x offset, so how much the camera's moved in pixels, and we have to divide that by tile width to get that in terms of tiles. If this right here is greater than 0, then we're going to use that, because that means the player has moved right. And there's tiles to the left that shouldn't be rendered. However, if we moved too far left, let's say, and we get a negative value for that, we're just going to change that to 0, that we don't get any errors. And it works the same for y. Now for the x end and y end, we simply take the minimum. So the width of our map, so the tiles far right of our world, is that smaller than this calculation right here. And it's the same thing as above, however we add the game's width, or the game's height in terms of y end, to the x offset, because we are now looking at the right of the screen, not the far left. Hopefully I explained that decent enough. That felt a little bit sloppy. If you need any other explanations, please let me know down in the comments below. Either I or someone else should answer your question. I apologize that we didn't do collision detection today, guys. I feel very bad, but I felt that I really needed to get something like the world class finished, at least for the time being. We'll be adding much more to this in the future. Thanks for watching, everyone, and I'll see you guys in the next tutorial.